Imagine falling, not off a bike, not off a diving board, but falling straight down into the ocean. You pass through the sunlit surface water, where dolphins play and sea turtles glide. Then the light starts to fade. By about 200 meters down, it is nearly gone. By 1,000 meters, it is completely, totally, permanently dark. And you are not even close to the bottom. The deepest point in the entire ocean, the Challenger Deep in the Mariana Trench, sits nearly 11 kilometers below the surface. That is deeper than Mount Everest is tall. So here is the question that should keep you up at night. What on earth is living down there? And the answer is so strange, so wild, and honestly so terrifying that scientists are still piecing it together today. Let us start with the pressure, because pressure is the deep ocean's first and most brutal fact. At sea level, the air above you pushes down on your body with a force called 1 atmosphere. Dive to the bottom of the Mariana Trench, and the water above you pushes down with more than 1,000 atmospheres of pressure. That is like having 50 jumbo jets stacked on top of every single square inch of your body. A styrofoam cup lowered to those depths on a research cable comes back the size of a thimble, crushed by invisible force. Human lungs would collapse in seconds, yet somehow life thrives. The creatures of the deep have had millions of years to solve the pressure problem, and the solutions they evolved are genuinely alien. Deep-sea fish like the barreleye fish, studied extensively by the Monterey Bay Aquarium Research Institute, have transparent heads. You can see straight through their skulls to their tubular eyes, which rotate upward to spot the faint silhouettes of prey above them. Their eyes are so sensitive that even the ghost of a shadow from a bioluminescent flash can trigger a chase. Bioluminescence, by the way, is light made by living things using a chemical reaction, and roughly 76% of deep-sea animals produce it, according to research published in Scientific Reports in 2020. Down in the dark, it is used to attract prey, to communicate, and sometimes just to confuse a predator into leaving you alone. Then there is the anglerfish, probably the most famous monster of the deep. The female anglerfish dangles a glowing lure from a spine above her enormous jaws. Any curious creature that swims toward the light gets swallowed whole because her stomach can stretch to fit prey twice her own size. The male anglerfish, meanwhile, is tiny, and when he finds a female, he bites into her skin and never lets go. His body fuses to hers. Their bloodstreams merge. He gives up everything except the ability to fertilize her eggs. The two animals become one. This was discovered and documented by scientists at the University of Washington and described in detail in the journal Science. But the creatures are only half the story. The environment itself is extraordinary. The deep ocean is not just dark and crushing. It is also brutally cold, hovering around 2 to 4 degrees Celsius in most of the abyssal zone. Yet in 1990, scientists aboard the research vessel Alvin, operated by the Hole Oceanographic Institution, found something that rewrote biology entirely. On the floor of the Pacific Ocean near the Galapagos Islands, they discovered hydrothermal vents. These are cracks in the seafloor where superheated water blasts out at temperatures above 400 degrees Celsius, loaded with toxic chemicals like hydrogen sulfide. And around those vents, packed in thick clusters, was life. Tube worms 2 meters long, ghostly white crabs, clams the size of dinner plates. None of these animals needed sunlight. They were running entirely on chemical energy, a process called chemosynthesis. Before this discovery, scientists believed all life on Earth depended on the sun. The deep sea proved that wrong. This discovery matters far beyond ocean science. If life can thrive in total darkness, under crushing pressure, in near freezing or superheated toxic water, then the rules for where life can exist in the universe just got a lot more interesting. Europa, one of Jupiter's moons, has a vast ocean beneath its icy crust. Enceladus, a moon of Saturn, shoots water vapor into space from vents that look remarkably like our own hydrothermal systems. NASA researchers have pointed to the 1977 Alvin discovery as one of the key reasons to search those moons for life. And we have barely explored any of this. NOAA, the National Oceanic and Atmospheric Administration, estimates that more than 80% of the ocean remains unmapped and unexplored. We have better maps of the surface of Mars than we do of our own ocean floor. Every time a new submersible dives to a previously unvisited spot, it finds species nobody has ever seen. The Schmidt Ocean Institute has documented new species on nearly every deep-sea expedition it has conducted in the last decade. So here is your payoff, the reason the deep ocean is both terrifying and completely wonderful. It is not terrifying because it wants to hurt you. It is terrifying because it is the largest living space on Earth. It operates by rules we are still learning, and it holds creatures so strange that they make the best science fiction look boring. The dark is not empty. It is full of glowing hunters, fused lovers, worms taller than a person, and entire ecosystems built around fire and poison in a place where no sunlight has ever reached. The deep ocean does not care that we find it frightening. It has been doing its thing for hundreds of millions of years, and it will keep doing it long after we figure out how to explore it properly. The only question is how many more impossible things are waiting down there for someone brave enough to look.